Example number 3. Okay, so for example number 3, okay, it is coming from past year question, semester 2, 2011 and 2012. So, if you look at the question, read the question carefully. Okay, you have a question indifference equation. Okay, means it consists of yn and xn relationship. So first, for you to sketch the digital filter structure, you must make sure your transfer function is in his z. Okay, so if you look at the question again, it must be in his z, means it is in z transform. Alright, so what you have to do is do the z transform for each time domain. Okay, means if you have yn, the z transform of yn is yz. Okay, what happens if you have x n minus 1? So z transform of x n minus 1, okay, you have a delay, okay, minus 1. Okay, means for z transform, you have to put z minus 1. Okay, next you have xn. So so z transfer of xn is xz. Okay, same goes to xn minus 3. So you're going to have z transform. So again, this one, z transform of minus 3 is z minus 3. So next, the function xn is xz. Okay, same goes, similar to yn minus 1, yn minus 2, yn minus 3. Okay, so the first question, determine the transfer function of the system. Means you need to find your hz. Hz equal to what? Okay, so as I did mention earlier, what you have to do first is you need to do z transform for each component. Okay, so after you do z transform, you will get yz equal to z minus 1 xz minus. Okay, next what you have to do is you need to bring yz at one part at z equal to xz. Okay, so okay, next what you have to do is you need to do factorization. Okay, so your hz equal to y over x. So what happened? We are going to bring down x under y. So we are going to bring down. Okay, so we bring down. So what happened? Here it is equal to so this is your transfer function. Okay, so done to determine the transfer function. Alright, so for the next question, you need to draw the structure of the system in direct form 1 and direct form 2. Okay, so based on the given transfer function. So your given transfer function, your determined transfer function is hz equal to okay, so first we are going to sketch direct form 1. Direct form 1 is non-canonic structure, non-canonic form. So in direct form 1, you are not sharing the same delay. Okay, not sharing the same delay for numerator and denominator part. Okay, so we have numerator part and then we have denominator part. Okay, so for direct form 1, okay, so we start with numerator part. Numerator part again at your right. So highest degree is 3. Okay, so we have 3 delays. Okay, so for the delays, make sure you put z minus 1, z minus 1, z minus 1. You cannot put z minus 1, z minus 2, z minus 3 for this one. Why? If you put z minus 1, z minus 2, z minus 3 for the third delay, you will have z minus 6 when you multiply them together. Okay, so which is actually not equivalent to the highest degree of your numerator part. That's why when you sketch the structure, make sure you have z minus 1, z minus 1, z minus 1, so that when you combine them, okay, when you combine them together, 1, 2, 3, it is actually z minus 3. Okay. Okay, let's continue. Okay, if you look at the numerator part, okay, we don't have a constant here. Okay, so for we don't have our first constant. Our first constant start after first delay. So after first delay, we have our first constant, which is 1. Next, after second delay, we have minus 1.2. After third delay, we have our third constant. So next, so done for numerator part. So let's start with denominator part. So it is non-canonic, means not share the same delay. So for denominator, we're going to have again 3 delays. Why? The highest degree is z minus 3. Okay, so we have first, second, and third delay. Okay, so we start with 1. So 1 is straight line. Okay, after first delay, we have positive 1.3. After second delay, we have negative 1.04. After third delay, we have positive 0.222. Next, we are going to combine them. Okay, done for direct form 1. Okay, so direct form 2 is canonic structure. Again, canonic means combine the delays. Okay, so we are going to combine the delays. Okay, so this we need to combine or share delays. See, share delays of numerator and denominator. Okay, so again, okay, I'm going to repeat this one again. Your hz is z minus. Okay, so this is canonic form, direct form 2 canonic. So for you to sketch direct form 2, you have to refer to your highest degree. Your highest degree for both is 3. So we're going to have 3 delays. Your numerator, we start after your first constant, start after first delay. So 1, After second delay, it is for denominator. Okay, we have 1. Okay, so 1 is straight line. Okay, next, after first delay, done for direct form 2. So that's all the 3 examples of chapter 8. Okay, so make sure you do your own revision.